Hello students, welcome to online maths classroom. This is part 2 of your topic trigonometric functions, and in this video we will learn about the solutions of exercise 3.2 and 3.3. So let us start with it. So exercise 3.2 and question number 1, which is your finding the values of other 5 trigonometric functions in exercises 1 to 5. Okay. So cos x is given here is minus half and x is lying in third quadrant. So we know that the value of cos is negative in third quadrant. That's why cos x is given as minus half. And you have to find the other 5 trigonometric functions. Okay. So cos x is minus half, x is lying in third quadrant. So the very first thing we can find from cos directly is secant. Okay, so this is one other method by which we can find the value of other trigonometric function, and the first simple one is you take it as your base upon hypotenuse, draw a right triangle. Okay, find out the unknown side, like if hypotenuse is given, then hypotenuse and perpendicular is given, find base and rest of the other whatsoever required, and then make the ratios by using p upon h, b upon h, p upon b, and all the ratios. Okay, all the trigonometric ratios using those ratio of the sides. Okay, so this is the second way. Cos x is minus half, so from cos x simply we can find secant x, that is the reciprocal, and that is minus 2, right? For sine, what we do, we will use the formula identity, sine square x is 1 minus cos square x. So 1 minus 1 by 4, that is 3 by 4. So sine x is plus minus root 3 by 2. Now in your third quadrant, sine is negative, so I'll retain the negative value. So sine x is minus root 3 by 2. Okay, and cosecant x is reciprocal of sine, that is minus 2 by root 3, and tan is the ratio of sine and cos, that is minus root 3 by 2 over minus 1 by 2, which is root 3, and tan will be positive, as in third quadrant tan is positive. Okay, cot is reciprocal of tan, which is your 1 by root 3. Number 2 is sine x is 3 by 5, x is in second quadrant, so sine is 3 upon 5. So very first thing we can find is cosecant x, that is the reciprocal of sine, that is 5 by 3. And for finding cos, we will use identity, cos square x is 1 minus sine square x. So 1 minus 9 by 25, that is 16 by 25. Cos x is plus minus 4 by 5, right? But in second quadrant, cos is negative, so I'll take cos x as minus 4 by 5. So secant will be reciprocal of it, minus 5 by 4. And tan is the ratio of sine is to cos, that is 3 by 5 over minus 4 by 5, that is minus 3 by 4. Okay, and in second quadrant, tan is also negative, that's why we are getting the negative value. And cot is minus 4 by. Number 3 is cot is 3 by 4 again. So first thing we will find is tan. Tan is reciprocal of it, 4 by 3. Now use identity, cosecant square theta is 1 plus cot square theta. I'll get cosecant as plus minus 5 by 4. Now in third quadrant, cosecant is negative, so negative value will be retained. Reciprocal of cosecant is sine, so it is minus 4 by 5. And your ratio of you can find means cos x by either using 1 minus sine square x, or I can use this way also, cos is divided and multiplied by sine, so that is it is cot x into sine x. Okay, so cot and sine both values are known, so it is minus 3 by 5, and reciprocal of cos is secant, that is minus 5 by 3. Okay, so this is also one way, and the other simple way is using the right triangle. You can frame the ratios. Secant x is 13 by 5, so first thing we will find cos 5 by 13. Using cos, sine square will be your 1 minus cos square x, that is sine x is plus minus 12 by 13. In fourth quadrant, sine is negative, so it is minus 12 by 13. Cosecant is reciprocal of it, minus 13 by 12, and tan is ratio of sine and cos, that is minus 12 by 5, and cot is minus 5 by 12. Tan x is minus 5 by 12, x lies in second quadrant. Okay, so cot is your 1 upon tan, that is minus 12 by 5. Now secant square is 1 plus tan square x, that is your secant x is plus minus 13 by 12. Okay, x is lying in quadrant number 2, so secant is negative. Okay, so it is minus 13 by 12. Reciprocal of it is cos, cos is minus 12 by 13. Then sine can be calculated, sine by cos into cos, or you can use that root 1 minus cos square x, that way also it can be done. So it is 5 by 13, and cosecant is 13 by 5. Find the values of trigonometric functions in exercises 6 to 10. So sine 765 degree. Okay, so you know that after 360 degree you can just find that values are repeating. So means if we are taking, say, these values as one cycle of 360 degrees complete, okay, so for 2 cycles 720 degrees complete here, okay, so 720 degree plus 45 will give you 765. So means we already reach in your first quadrant. So it is 2 times 360 plus 45, right? So again, any times it is reaching, we are in first quadrant. So at 360 there is no change, so it will be sine x itself, okay? So that means it is sine 45, which is 1 by root. Cosecant minus 1410 degree means cosecant is your, it's an odd function, so it will be your minus times cosecant 1410 degree, okay? And again, it can be written as cosecant 4 into 360 degree minus 1410 degree. Okay, in that way also we can write. So it is your, again we are in means 1410 means it is, you are getting the value as cosecant 30, right? So because it is negative, 4 rounds after this means 4 rounds you are taking, and 360 minus will be lying in your fourth quadrant, right, where cosecant is negative, so it will be your minus cosecant 30 degree, that is 2. Tan 19 pi by 3 can be written as tan your 18 pi by plus pi by 3, okay, so that means it is 6 pi plus pi by 3, right? So again it is 3 into 2 pi plus pi by 3. Again we are in first quadrant, that is 10 pi by 3, and answer is root 3. Sine minus 11 pi by 3, okay, it is means either you write it as minus times sine 11 pi by 3 and then change, or you can write it as 7 your sine of 4 pi minus 11 pi by 3, okay, that way also this negative sign is balanced, okay. So sine pi by 3 is root 3 by 2, we can get it from here. Cot minus 15 pi by 4 is your, either you can write as minus cot 15 pi by 4, then you can break 15 pi by 4, or you can just change it to cot of like your 4 pi minus 15 pi by 4, okay, so that is your pi by 4 itself, and the answer is 1. Exercise 3.3 is prove that sine square pi by 6 plus cos square pi by 3 minus tan square pi by 4 is minus half. So all thing is that you will put the values of sine 30 is half, your cos 60 is half, and tan 45 is 1, okay. And sine square pi by 6 means sine pi by 6 whole square, so that means you have to take the whole square of the values whatsoever values we get, and the answer is minus 1 by 2. For the second one, again your sine pi by 6 is half, cosecant 7 pi by 6 you need to break it as like cosecant pi plus pi by 6, which is your minus cosecant pi by 6, and the value is minus 2, and cos pi by 3 is half. Put all the values like 2 into half square plus minus 2 whole square and into half whole square, which is your 3 by 2. In third one, cot square pi by 6, so cot pi by 6 is root 3, cosecant 5 pi by 6 can be written as your cosecant pi minus pi by 6, which is cosecant pi by 6, that is 2, and tan pi by 6 is 1 by root 3, okay. Put all the values, take the squares, and 6 is the answer. Again, sine square 3 pi by 4 can be calculated as sine pi minus pi by 4, which is your sine pi by 4, which is 1 by root 2, cos pi by 4 is 1 by root 2, and secant pi by 3 is 2. Put all the values and you will get the value as 10. Now to find the value of sine 75 degree, we can break sine 75 to known angles like sine 45 plus 30. So use the formula sine A plus B as sine A cos B plus cos A sine B. So sine 45 cos 30 plus cos 45 sine 30. Now sine 45 is 1 by root 2. This is root 3 by 2 plus 1 by root 2 and 1 by 2. So it is root 3 plus 1 upon 2 root 2. Similarly, tan 15 can be calculated as tan 45 minus 30. Use the formula of tan A minus B is tan A minus tan B upon 1 plus tan A tan B. Okay. So tan 45 is 1, 30 is 1 by root 3. Okay. And again is 1 plus 1 into 1 by root 3. Take LCM, it is root 3 minus 1 upon root 3 plus 1. You can rationalize it to a bit because we want to express it as simple terms. So it is root 3 minus 1 whole square upon, this is A plus B into A minus B, that is 3 minus 1, that is 2. Okay, so take your 2 common from the numerator, and after cancellation I get it as 2 minus root 3. Number 6 is cos pi by 4 minus x cos pi by 4 minus y minus sin pi by 4 minus x sin pi by 4 minus y. Okay, you have to prove it equal to sine of x plus y. Now see, this formula is of the form as cos A cos B minus sin A sin B. So cos A cos B minus sin A sin B is a form of cos A plus B. Now here A is your pi by 4 minus x and B is cos pi by 4 minus y. Okay, so this formula changes to cos of A and plus B. So pi by 4 plus pi by 4 is pi by 2, and this is minus times x plus y, and cos 90 minus theta is sin theta. So this is the required. Number 7 is tan pi by 4 plus x upon tan pi by 4 minus x equal to, you have to prove it equal to this term. So tan pi by 4 plus x, use the formula of tan A plus B, that is tan A plus tan B upon 1 minus tan A tan B, tan A minus tan B upon 1 plus tan A tan B. Tan pi by 4 is 1, so it changes to 1 plus tan x upon 1 minus tan x upon 1 minus tan x upon 1 plus tan x. Now take it to numerator, these both will come together and we'll get it as 1 plus tan x upon 1 minus tan x whole square. Number 8 is cos pi by 6, pi plus x cos minus x sin pi minus x cos 90 plus x is cot square x. Okay, so cot 1 is 80 plus theta is your minus cos theta. Okay, cos of minus x is, it is an even function, so it is just cos x. Sin 180 minus theta is sin x, and cos 90 plus theta is minus sin x. Okay, it is 90 plus theta in second quadrant and changes there at 90, so it is minus sin x. So this negative negative gets balanced. Okay, so it becomes your cos square x upon sin square x, that is cot square x. Number 9 is cot, your 3 pi by 2 is 270 plus x. Okay, 270 plus x, then it is cos 360 plus x, it is cot 270 minus x, and it is cot 360 plus x. Okay, so now you know that cos 270 plus x, right? We are in fourth quadrant and cos is positive there, and definitely cos will change to sin x. And cos to 360 plus x, no change, so it is cos x as we are talking about the first quadrant. Cot 270 minus x means it is in the in your 270 minus x is third quadrant. It is self quadrant of cot and tan both, so it will be positive tan x, and this is your again first quadrant, it is cot x. Okay, now this is sin x cos x, change to sin cos, take LCM, numerator becomes 1 and denominator gets cancelled, and we get the answer as. Number 10 is again a formula, like it is sin A sin B plus cos A cos B, or we can read it like cos A cos B plus sin A sin B, which is the formula for cos of A minus B. Now who is A? A is your, you can take the bigger angle as A or smaller one also, so it is A is your n plus 1 x and B is n plus 2 x, so it becomes cos A minus B. Open the brackets, you'll get it as cos of minus x, as cos is even, so it becomes cos x. Number 11 is cos, it is the formula you can use is cos A plus B minus cos E minus B. So what is the formula for cos A plus B? It is cos A cos B minus sin A sin B. Similarly, the formula for cos E minus B is cos A cos B plus sin A sin B. Open the brackets, you will find that your means some terms will be cancelled, like which terms will be cancelled, like it is cos 3 pi by 4 x into cos x minus sin 3 pi by 4 into sin x minus cos 3 pi by 4 into cos x, okay, and minus sin 3 pi by 4 into this. Okay, so means your this terms gets cancelled with this, so we just get it as minus 2 times sin 3 pi by 4 into sin x. Okay, so it is minus 2. Now let's change to sin 3 pi by 4 to your you can change it to pi minus pi by 4. So after taking LCM, it becomes 4 pi minus pi by 4 like this. Okay, and this is sin x itself. So sin 180 minus theta is your sin theta again, second quadrant. Okay, and no change of at 180 degree. So it is sin pi by 4 is 1 by root 2. Now rationalize it, minus 2 by root 2. You'll get it as minus root 2 sin x. Number 12 is sin square 6x minus sin square 4x. You have to prove it like this. So there's the formula for sin square A minus sin square B, which is sin A plus B into sin A minus B. Okay, this formula can be proved by opening this result also, or opening sin A plus sin B into sin A minus sin B. That way also this result can be obtained, as we have discussed in our class. Okay, so it becomes sin A plus B into sin A minus B, which is sin 10x into sin 2x. For cos square A minus cos square B, right, the same formula can be changed as this. You can just change it to sin square A minus sin square B we used, as sin a plus b into sin a minus b, right? In same way, cos square a minus cos square b, it is means remember that it is not equal to this. Okay, so definitely you know that I can change it to this to sine square form. So it is 1 minus sine square 2x, okay, minus 1 minus sine square 6x. So formula changes to sine square 6x minus sine square 2x. So this above formula, this one can be used again to get the value as sine 8x into sine 4x. Number 14 is sine 2x to sine 4x plus sine 6x. Okay, now arrangement is that you have to combine those one whose application of formula, as you have to do a plus b by 2 and a minus b by 2, fractional terms are not involved. Okay, so in that way, so that means, and also the formula is applicable when sine is not having, means any trigonometric function is not having something like 2 sine x or 3 sine x, something like this. Okay, so I'll arrange this both of them together and firstly apply the formula to both of them. Okay, so and take as the sign is of plus, so take the bigger angle at first and the smaller one as second place, so that we do not get unnecessarily negative signs. Okay, so use the formula of s plus s. What is s plus s? It is 2sc. Okay, so it becomes 2 sine a plus b by 2 into cos a minus b by 2, and this is plus 2 sine 4x. Okay, so this changes to 6 plus 2 by 2 is 4x, and this is cos 2x plus 2 sine 4x. Take 2 sine 4x common, so we get it as cos 2x plus 1. Okay, so the formula for cos 2x is your 2 cos square x minus 1, right? This will get cancelled and we get the answer as 4 cos square x into sine 4x. In number 15, we have to prove both sides equal. So here you have to apply the formula for s plus s, which is 2 sine a plus b by 2 into cos a minus b by 2. Now open this cot as your cos upon sine. Okay, this cos upon sine, and you will get that the terms will be cancelled here. Okay, in the second case here also you will get your cos upon sine, and this is your s minus s is 2 cos a plus b. So this gets, you get 2 cos x, cos for x. Okay, and here also you will find that this is your sine 4x and this is your cos x. Okay, so this cos 4x upon sine 4x will cancel, and you will again get both equation number 1 and 2 same. Number 16 is your cos 9x minus cos 5x upon cos 17x minus sine 3x. Okay, so apply the formula of c minus c at the top, which is minus 2ss minus 2 sine a plus b by 2 sine a minus b by 2, and s minus s at the bottom, that is 2 cos a plus b by 2 into sine a minus b by 2. Okay, so you get sine 7x sine 2x cos 10x sine 7x. Okay, so you get the answer as minus sine 2x upon cos 10x. Number 17 is again use the formula s plus s at the top, 2 sine a plus b by 2 cos a minus b by 2, and here it is 2 cos a plus by b by 2 and cos a minus b by 2. Okay, cancel the common terms and you get the answer as sine upon cos will give you tan 4x. In number 18, s minus s is 2 cos a plus b by 2 sine a minus b by 2, and c plus c is 2 cos a plus b by 2 into cos a minus b by 2, right? So this gets cancelled and we get it as tan x minus 5 by 2. In number 19, s plus s is 2 sine a plus b by 2 cos a minus b by 2, and c plus c is 2 cos a plus b by 2 into cos a minus b by 2. Okay, so cancel the common terms and you get tan 2. In number 20, it is your s minus s at the top. Okay, s minus s at the top. So what you can do is, again, we don't want unnecessarily negative signs, so take negative sign common from both numerator and denominator. The denominator changes to, this is the formula for cos 2x, and here it is 2 cos a plus b by 2 sine a minus b by 2. Okay, so cos 2x changes and we get 2 sine x as the answer. In number 21, little bit rearrangement is required, and again you have to arrange those ones where fractions are not involved. Okay, because if fractions are involved also, we must take them at the last only. So arrange cos 4x and cos 2x. Okay, leave this cos 3x and sine 3x from here at last. Apply the formula for c plus c, 2 cos a plus b by 2 cos e minus b by 2, and s plus s is 2 sine a plus b by 2 cos e minus b by 2. So this becomes your 2 cos 3x and cos x plus cos 3x, and 2 sine 3x cos x plus sine 3x. Take what you can take common. You can take cos 3x from numerator common. you get 2 cos x plus 1 and sine 3x as common, 2 cos x plus 1. Okay, so this gets cancelled and we get cot 3x as answer. Number 22 is cot x cot 2x minus cot 2x cot 3x minus cot 3x cot x equal to 1. Okay, so you know that in such questions one of the angle is sum of other two. So you can you do it by the tan formula also, and then change it to 1 upon tan form, that is cot, or directly apply the formula of cot. So cot a plus b, apply the cot a plus b formula, which is cot a cot b minus 1 upon cot b plus cot a. Okay, so this is a, this is b, cot a cot b minus 1 upon cot b plus cot a. So cross multiply, open the brackets, bring this negative sign to other side, and you will get the answer. Number 23 is tan 4x is 4 tan x upon into 1 minus tan square x upon 1 minus 6 tan square x plus tan 4x. So you can do it like my tan 3x plus x, okay, but the simple way is your tan 2x, okay, which is the formula is 2 tan a upon 1 minus tan square a. Okay, take a as 2x. So what will be the formula for tan 4x will be your 2 tan. Okay, here angle is half, then here it is twice. So if it is 4, then here it will be 2 times. So 2 tan 2x upon 1 minus tan square 2x. Again change tan 2x by this formula, 2 tan x upon 1 minus tan square x. Here also 2 tan x upon 1 minus tan square x whole square. Now take LCM, 4 tan x upon 1 minus tan square x and 1 minus 4 tan square x upon 1 minus tan square x whole square. Open the square, take LCM, okay, and you get 4 tan x, and then upon 1 minus tan square x, this is your 1 plus tan 4x minus 2 tan square x minus 4 tan square x upon this. Okay, now one of this will get cancelled with one power, and this one power will get arranged with this. So we get 4 tan x into 1 minus tan square x upon 1 minus 2 tan square x plus tan 4x minus 4 tan square x. So this 4 and minus 2 will give you minus 6 tan square x plus tan 4x. Number 24 is again writing cos 4x as cos 2a, and the formula conversion, because it is of the form 1 minus something, so we will convert 1 minus 2 sin square a. So here if the angle is 2a, here the angle is a half, so 4x is there, so here it will be 2x. So sine square 2x is like sine 2x whole square. The formula for sine 2x is 2 sin x cos x whole square. Now open it, you will get 2, and into 4 is at 8, and sine square x cos square x. Number 25 is cos 6x, okay, and you have to change it completely to cos. Okay, the result is completely in terms of cos. So again cos 2x, the conversion we will use is the complete cos conversion, like 2 cos square a minus 1. So for cos 6x, so for if angle is twice, it is half, so for 6x it will be 3x. Now it is like cos 3x whole square, so I'll apply the formula for cos 3x, which is 4 cos cube x minus 3 cos x whole square. So it is your 16 cos 6x, open as a minus b whole square, minus 24 cos 4x plus 9 cos 4x minus 1, open the bracket, 32 cos 6x minus 48 cos 4x plus 18 cos square x minus 1. Okay, so this is all regarding both the exercises 3.2 and 3.3. I hope whatever is discussed is clear to you. Thank you so much.